For any enterprise executive, there is a specific status update that overrides all priorities: learning that a core platform has gone off the air. Network downtime triggers an immediate, cascading drop in human performance across every department. Disconnected messaging silos take hold. Without reliable communication, operational momentum stalls, and project execution is delayed. Those internal delays quickly bleed outward. Customers experience missed deliverables, and partner trust erodes. We have evolved from legacy analog systems to a hyper-connected IP matrix, but that connectivity makes us entirely dependent on the underlying infrastructure. Unified Communications, or UC, was designed specifically to eliminate these human delays by integrating chat, video, and data into a single cohesive channel. However, deploying a generic one-size-fits-all network to support that UC platform guarantees failure. Technical requirements are never uniform. The demands placed on a network diverge sharply depending on the specific industry it serves. A network is a highly customized engine. Its architecture must be dictated entirely by the precise operational constraints of the organization using it. We can map these constraints across specific industries, starting with the strict data payload and security requirements in banking and financial services. This architecture diagram maps a financial institution directly to consumer endpoints via the internet. In this sector, the absolute mandate is confidentiality and integrity. The network must secure multimodal trade alerts and encrypted video endpoints at automated teller machines. Moving to healthcare, we see a different topology, connecting diverse endpoints to a central node. While it shares banking's strict security needs, its primary goal is different. The network must eliminate human delay in life-threatening situations via high-speed specialist links. K-12 and higher education present another distinct structure, with specific nodes dedicated to students, teachers, and administrators. The priority here is available data. This infrastructure must support interactive grade distribution and heavy traffic during peak registration. Commercial retail shifts the focus entirely. This diagram centers on a retail storefront connecting equally to multiple consumer blocks. The goal is to reach new prospects, stand out in a crowded market, and provide live customer service directly to those consumer endpoints. In manufacturing, the defining constraint is just-in-time inventory. This diagram highlights distinct supply chain nodes: suppliers, wholesalers, and consumers. JIT requires a hyper-efficient automated network loop to seamlessly link purchasing and supply chain management, so materials arrive exactly when needed. Finally, travel and transportation networks rely on unique logistical endpoints, focusing heavily on shippers and travelers communicating over the internet. This industry requires real-time voice-over-IP tracking and heavy reliance on RFID chip automation to orchestrate fleets and expedite check-ins. An architecture that ignores these vertical constraints leaves a business with critical vulnerabilities, from security gaps in finance to life-threatening delays in emergency care. The second major axis of network design is the physical and economic scale of the organization, as the footprint shrinks down to a localized node. Enterprise-scale organizations face a distinct challenge. They must balance the advantages of massive economies of scale against the heavy logistical burden of geographically distributed offices. These enterprise networks navigate complex hosting infrastructures, integrate multiple modes of business communications, and manage extreme latency across different time zones. Small and medium-sized businesses operate under a different constraint. They must maximize severely limited IT resources to reach prospects and service customers. SMBs deploy unified communications specifically to level the playing field, utilizing comprehensive customer service tools to project a large company perception to the market. At the most localized tier, the small office, home office, relies heavily on third-party cloud services. By leveraging these cloud technologies, SOHOs extend their organic reach and respond rapidly to customer needs without massive initial capital expenses. Organizational scale dictates both the sheer size of the network footprint and the exact type of physical infrastructure investment required to remain competitive. The public sector introduces a unique anomaly into network design. Government agencies operate under rigid statutory regulations designed to prevent the waste of taxpayer money. The primary method of procuring services and products here is the request for proposal, or RFP process. It is mandatory and highly scrutinized. In this environment, unified communications must operate as a strict compliance engine rather than a simple collaboration tool. The UC system is programmed to automatically document every single point of contact during the entire RFP timeline. To avoid undocumented information exchange, the network must physically deny unauthorized vendor contacts and redirect them strictly to approved channels. The system also utilizes automated alerts to warn managers when critical mandatory actions or deadlines are approaching. In the public sector, absolute, verifiable compliance is the definitive metric of network success. Translating diverse needs into functional networks means organizations cannot simply guess at a layout. This flowchart illustrates the mandatory requirements engineering pipeline for solving organizational communication challenges, mapping people, processes, and information down to specific technology solutions. Step 1 focuses on the functional reality. We must identify the abstract business problem or operational bottleneck hindering the organization. For example, organizations might identify high latency during peak hours or fragmented communication channels. Step 2 formulates the functional requirements. This defines exactly what the system must achieve from an executive or end-user perspective. This could be the need for real-time presence indicators, encrypted remote specialist links, or secure remote access. Step 3 develops the technical requirements. This is the crucial stage where functional needs are translated into hard network specifications. Engineers calculate specific bandwidth allocations, evaluate endpoint quality, and configure precise Layer 2 and Layer 3 topologies. Skipping any step guarantees a solution that wastes resources and falls short of expected functionality. Modern managers must map precise technical specifications dictated entirely by their vertical to prevent breakdowns. Mastering this pipeline ensures an enterprise network stays online, compliant, and optimized, so you never hear the words "off the air."